3.3 is when we reintroduce logarithmic functions. Okay? We're going to reintroduce logarithmic functions. Now, with that in mind, we did logarithmic functions back in Algebra 2, right?
A little bit.
Okay, so some of this is going to seem familiar. Some of it's going to be new. I'm basically going to go through a bunch of rules here, some connections, because one of the big things we do with logarithms is we connect it to exponential functions, which is why we've spent the last 2 lessons working on exponential functions. Now we're going to work on logarithmic functions, okay? So, logarithms. The big connection right here is that an expression, log base b of x equals y, is equivalent to the exponential expression b to the y equals x. Okay, so the log equation, log base b of x equals y, is equivalent, exponential form, b to the y equals x. Now, I tend to use the phrase left, right, middle. Let me remind you, left, right, middle. When we look at log, the base is the left, the y is the right, the x is the middle. So when I rewrite it over here, the base on the left raised to the y on the right is equal to the x from the middle. And that's kind of an easy way to remember how to rearrange your terms. Okay, when you're going between log and exponential form. Okay, I tend not to go the other way, but you can also go the other way a little bit, in that we can look at it and you can undo your left, right, middle, I guess is what I want to say. Okay, and we'll talk about that a little bit as we go. Now, so in this first set, it asks us to evaluate the following logarithms. Okay, if you recall from last year, this is not just hitting the log button on your calculator, because the log button on your calculator is going to be base 10. Okay, this is understanding the setup. So I want to know what is log base 2 of 8 equal to. So I'm going to start, and I'm going to say this is equal to y. Okay. Now, how do I get out of log form here? Left, right, middle. So how's this going to rewrite if we talk left, right, middle?
2 to the y.
The 2 on the left raised to the y on the right equals the 8 in the middle.
That's the answer.
That's not the answer. My answer is I want to know what y is.
Oh, y.
Y is 3, because 2 to the third is 8. Now, I am going to write it, one thing here is that, and this will help on more difficult problems, 2 to the y, what is 8 rewritten as a base of 2? It's 2 to the third, yes? And in fact, last year, you had either a blue or a gold paper that had some powers on it to be helpful.
Yeah.
Okay, I haven't got to those yet. I might be able to dig them out, but for right now, we're going with what we know. If the bases are the same, then the powers are equal, right? Are we okay one way or the other with y equals 3? Or basically log base 2 of 8 is equal to 3. And we'll talk about some properties we could use here in a little bit too. Okay, B. Log base 3 of square root of 3. I want to know what that equals, so I'm going to set it equal to y.
3 to the y equals square root of 3.
Okay. 3 to the y is equal to the square root of 3.
3 to the 1/2.
Okay. What is the square root of 3 rewritten with a power? The square root of 3 is also 3 to the 1/2, yes? So you can say 3 to the y equals 3 to the 1/2, or in other words, this log is equal to 1/2. Okay?
Basically, we're just finding y.
Yeah, we're finding what the log equals, and I'm making that y, just so we have a variable to work with. You can make it x, you can make it L, you can make it whatever variable you want. You're just trying to find what the log equals. So I'm putting a variable in there. Log base 5 of 1/25 equals to y. 5 on the left raised to the y on the right is equal to the 1/25 in the middle. What do you know about 1/25? What do you know about 25?
Square.
How about 1/25 is 1 over 5 squared, yes? What do you know about 1 over 5 squared?
It's 1 over 25.
1 over 5 squared is 5 to the -2 power, right? Because how do you get a power out of the denominator? You make it negative, remember? You make powers negative when you go across that fraction bar. So now, I took 1 over 25 and changed it to 5 to the -2nd. 5 to the y equals 5 to the 2nd. What is this expression equal to?
-2.
-2. Okay. D. Log base 4 of 1. I'm going to set it equal to y.
4 to the y is equal.
Okay. Left, right, middle will take us out of log form. 4 to the y equals 1. What's the rule here we need to know?
Y is equal.
4 to what power is 1?
Oh, 0, yeah.
Anything raised to the 0 is 1. So I could rewrite this as 4 to the y is equal to 4 to the 0. But basically, yeah, it was a power of 0. Now, what you're going to learn here in a moment, log of 1, no matter the base, is always 0. Log of 1, no matter the base, is always 0. We're going to talk about that here in a moment. Okay. E, log base 7 of 7 is equal to y. I'm just being consistent. I'm sticking with y. What do we know here? Left, right, middle. 7 to the y is equal to 7. 7 to what power? The first, right? 7 to the y is equal to 7 to the first, and so y is 1. There's another rule we're getting ready to learn. Okay? When your base and your inside of your log are the same, it's always going to be equal to 1. So if that had been log base 99 of 99, I'd still know it's 1. Okay, those are basics. Okay, set it up, do a left, right, middle. Properties of logs. Okay, we're gonna do some more problems. They're just like the ones we just did, but we're gonna use properties of logs to do them. Okay, in the homework, pay attention to the directions. But we've got 4 properties. I've already mentioned 2 of them. Log base b of 1. Log any base when it's log of 1 is always 0. Property 2. When the base and the inside of the log are the same. So log base b of b, when those are the same, it's always going to equal 1. That was my log base 7 of 7. Now, two other ones. 3. Log base b of b to the y is equal to y. So this is saying if your base of your log and the base of the inside are the same, it's going to be equal to the power. For instance, that's the property we kind of used on A and B. We just didn't have the property at the time. Because this would be log base 2 of 2 to the 3rd. It was equal to 3. This would be log base 3 of 3 to the 1/2. It was equal to 1/2. And then the 4th one, kind of a special case. But when you have a base of b raised to a power of log, where it's also base b, then it's equal to the y right there. So again, if those b's match, those bases match, it's equal to whatever's inside the log. Okay? Those are 4 properties you need to know. We need to know how to use them. Got it? Okay, let's go through these examples on example 2, and let's use our properties. So instead of setting them equal to y and doing a left, right, middle, we're going to use our properties. So log base 3 of 27. I want to know what it equals. What do you know about 27?
It's 3 to the 3rd.
Okay. This can be rewritten as log base 3 of 3 to the 3rd. Now, it's a lot of 3's. What is this equal to?
3.
Can I be specific and say which 3 is it equal to?
The top right.
Okay.
The exponent.
The exponent. So, basically, because these 2 3's are the same, my answer is the exponent, which just so happens to be 3. Sorry, bad example, I guess. Are we okay with that one? It might make more sense on this next one, because this next one is similar. Log base 2 of the square root of 2. Well, what do you know about the square root of 2? How can that be rewritten?
2 to the 1.
So I can rewrite this as log base 2 of 2 to the 1/2. So what is this log equal to? 1/2, yes? The 2's are the same. Since those 2's match, it's equal to the exponent, which is just 1/2. Okay, C. Log base 25 of 25. What'd you say?
1.
1. Now, what's our reasoning? Which reasoning do we want to use?
The second one.
Okay.
Being abused.
Property 2, when the base of the log and the inside of the log are the same, it's just equal to 1. We can also relate it to property 3, which is the same property I've used on examples 1 and 2. This is log base 25 of 25 to what exponent? The first. Am I now using the same property I used on A and B? It's equal to the exponent. Okay, and that was because those guys matched. D, 6 raised to the log base 6 of 7.
7. There's the fourth one.
Okay, property 4, you guys there? If these match, it's equal to the y. What do we have here? 6's match, so it's equal to the 7. And again, that's because the 6's match. And E, log base 8 of 1.
0.
Log of 1, any base is 0. That is property 1. Not that you have to know the property numbers, I'm just trying to relate them back to you. Okay, I've been moving fast. Are there questions I need to pause and answer? Okay, for the moment. Okay, if you have a question, stop and ask me, okay? Moving forward, folks, as we move forward throughout the rest of this chapter, we're going to be dealing with logs. So these properties are properties we need to be familiar with, that we can use, because they are going to come up in what we do. Now, the next thing we're going to talk about are what we call common logs. When you see the word abbreviation, whatever I want to say there, log, L-O-G, all the ones we just did had a number, a base written next to it, yes? However, they don't have to have a base written next to it. And what this is a common log is base 10. If you see log of x without a base written, we assume it is 10, which is called the common log. Okay, if it's anything other than 10, it has to be written in. But log base 10 is the common log. Now, what's your calculator working? Your calculator works in log base 10. Here's what I'm going to tell you, though. The directions here say evaluate each of the following without a calculator. So that means I'm going to need a little proof. Basically, we're using our property still. I'm going to need a little proof that there was a property used here, which is just basically showing a rewrite that shows the property. So, A, log of 100. You can give me an answer if you want, but I'm going to want to know how we get to that answer. What do you know?
Well, 100's 10 times 10.
Are you with them? 100 is 10 times 10, yes? Or in other words, I can write it as log of 10 squared. And that's important because what base is this? It's base 10. You write log of 10 squared. Now I'm going to believe you when you tell me the answer is what?
2.
2. Because the 10s match, so it's equal to whatever the exponent is. Okay?
Yep.
So in other words, basically writing log of 10 squared, there's your proof that you didn't just do it on the calculator. Okay. Thoughts on B?
Log of 10 to the 1/5.
Yeah. How do we do a fifth root?
You just
A fifth root
take the outside.
is the 1/5 power, right? So if you're going to write log of 10 to the 1/5, now I'll believe you when you tell me the answer is what?
1/5.
1/5. Now, I'll be honest. You tell me the answer is the decimal 0.2, I'm going to be more likely to believe you use the calculator. Fair enough? Okay. And again, that's because it was log base 10 of 10 to the 1/5. Okay, what about C? Log of 1/1000th. What do you know about 1,000? It's a multiple of 10, yes. It's a 1 with 3 zeros, so it's 10 to the 3rd, right? I see 3 zeros, so I know this is 1 over 10 to the 3rd, if you will. Or what do we need to think about here? When you take it out of the denominator, it's negative. So it's log base 10 of 10 to the negative 3rd. 10s match, so this log is equal to -3. Okay, D. 10 raised to the log of 6. Six? Is that what you said? It's 6 because what? We've got a 10 here. And what base is that?
10.
Base 10. And I get it. There's not really work to show for that one other than writing in the base 10. I get it. There's not work to show for that one, but.
0.
And E. Not really work to show for this one. Log of 1, any base is?
0.
0. Okay, getting the basics?
Yep.
Okay, the next section, the section you've been waiting for. Will you have a section like this in homework?
I hope so.
You will. Evaluate the following using your calculator. Basically, the hardest part is finding the log button, yes? Is it on the left?
Yeah.
It's right below the x squared, or the square root.
Log button's over there on the left. Folks, it is type it in. It is not a difficult task. I don't even think you need me to demonstrate. You find the log button and you type it in. I have my answers to 3 decimal places in this section. What are we getting on this one?
538.
Okay. This is approximately 1.538 according to the calculator.
You want 3 decimals on one?
I think so. What about B? Log of 0.43.
Negative 367.
Negative 0.367. Is he right, I hope?
Yes.
I say I hope because I wrote it down without looking. Now, notice, log of a number bigger than 1 is a positive answer. Log of a decimal less than 1 is a negative answer. What about log of negative 3?
0.47.
Non-round answers.
What did you do?
Well, couldn't you just make it? Oh no, because it's not a power.
It's not a
I was
power.
thinking of a power.
Okay, I was like, what did you do?
Not really, actually.
Okay, so this is where in my notes I have it written as undefined. You cannot take the log of a negative value, ever. It is undefined. It doesn't exist. I know you guys are going to laugh at me when I say, do you remember those graphs from lesson 1.3?
No.
Okay. One of the graphs that we learned way back when was the log graph. And the log graph looks like such. Okay? The log graph looks like such. Notice, where does it never go past?
Negative.
It never goes negative. It never goes past the y-axis. Okay? So, there you go. So, your domain there is only positive real numbers. And it does cross through here at 1. So, if you want to write anything to yourself, domain is positive real numbers. Okay? So, log of a negative, you can't do it. Your calculator is always going to remind you of that. Okay. Ready for example 5? Example 5 asks us to solve some more log equations, although these are actual equations where there's already an equal sign. And it says by changing to exponential form. Solve each equation using the definition and laws of logarithms. So when I say log of x equals 3, we need to take this out of log form and into exponential form. What do you know?
10 to the
10 to the
third
third
equals
equals
x.
Okay, this is an invisible base 10. So 10, left, right, middle. 10 on the left, raised to the 3 on the right, equals the x on the middle. And did this problem just become incredibly easy?
No.
What is 10 to the third?
Equals x.
10 to the third is 1,000. Okay. Not all going to be that easy, but we'll enjoy the easy ones when we can. What about B? Log base 2 of x equals 5. How do I rewrite?
2 to the 5th equals x.
Okay. 2 on the left, raise a 5 on the right, equals the x on the middle. Another easy one?
32 equals x.
Okay, we're just taking it out of log form, putting it in exponent form. So left, right, middle. And 2 to the 5th is 32. Where's all my help? Okay, C. This one's going to change things up a little bit. Log base 3 of 1/9 equals x. There's two different ways we could go here, depending on what you see.
I would say 3x to or 3 to the x equals 1/9.
Okay, left, right, middle, yes.
Then we know 1/9 is equal to 1 over 3 squared, which is really just to the negative second.
Okay,
3 to the negative second.
so we can still do left, right, middle. Base of 3, raise the x on the right, equals 1/9. When we rewrite this, kind of what we're doing up top, right? 1/9 is 1 over 3 squared, or 3 to the negative second. And so then, yes, x is -2. Now, I would argue there's another way you could have done that if you wanted. Not saying you'd have to. What'd you say?
Log of 3 to the 1 over 3 to 2 and then equals 3 to 2.
Yeah. If you just go back right here and rewrite this original, it's log base 3. 1/9 is 3 to the negative second. Can we use that property where if the 3's are the same, it's equal to the exponent? You can. Which is better? The one you see. Fair enough? You use what you see. Okay, D. Log base x of 64 equals 3.
X to the third equals 60.
Left, right, middle, x to the third equals 64. Okay. Cube root. The other option is I could rewrite this as x cubed equals 4 cubed. It's the same idea. Either way, x is 4. Yes? Okay. Are we okay? Okay. Example 6. You ready?
Born and raised.
We just talked about common logs. Now we're talking about something called natural logs. Natural logs use the natural number e. And so if you have a log base e, you're not going to see it written as log base e ever. You're going to see it written as natural log, which is ln of x. It's just a different abbreviation. It still means log. It just means log base e instead of any other base. Okay? Now, this first set says to evaluate without the calculator, which means we're using our rules, right? So natural log is what base did we say? Base e. What do you know? How could we rewrite the square root of e? E to the 1/2, yes? Do you see where I'm going with this? It's a base e. It's e on the inside. What is this log value equal to? What is this equal to?
What is
The exponent of 1/2. Are we okay with that? It's that same property. This is like the third time we're using these properties, right? Okay. What about B? Yeah. If you want to rewrite it, as a reminder, there's your base e. You don't have to write that in, but e to the 5th, what's this equal to?
5.
5. The e's match, so when these guys match, it's equal to the power. And what about C?
4. Yeah.
I'm there. Are you guys there? Why is it equal to 4? Because this is a base e here, and what's the base of this log?
E.
E. When those e's match, it's equal to that right there. Okay. Example 7. The next best part you've been waiting for. Use your calculator. What do you do different on the calculator?
Just push the natural log button.
You use the natural log button, which is right below the
Log button.
common log button. Okay. I am again going for 3 decimal places. There are 3 decimal places in homework. I took a peek at the answer key. What's the natural log of 23.5?
Roughly 3.157.
Okay, approximately 3.157. What's the natural log of 0.48? Negative 0.734. Challenge yourself without a calculator. What's the natural log of negative 5?
It's undefined.
It's undefined. For the same reason the last one was undefined. Okay, you can't do any log of any negative value. It is undefined. Okay? That's probably our best stopping spot, isn't it? Okay, so here is the official plan. Tomorrow, we will come in and spend a little time talking about graphs. And then, after we spend some time talking about graphs, you will have the remaining time to work on your 40 problems of homework.
I mean, it is 40 of them.
If we get the graphs done quick enough, I would venture to say you could get homework, I don't know. I feel like it's not horribly out of reach to say you could maybe get homework done in class. I don't know. Depends how quickly we get the graphs done. But again, I'm going to tell you, don't knock the 40 problems until you get in there and start working on them. Okay? I'm going to tell you this is still going to be one of the shorter homeworks you've had this year compared to some.